Okay, John, I think we can start, if you will.
Okay. Good morning, ladies and gentlemen, and thanks again for attending a combined session of the U3A Overberg Geoscientists Group Zoom presentation. I would just like to very quickly introduce H Cawthra and thank her for making the time to talk to us today, and then she will also be participating in the field trip to the east side of Walker Bay tomorrow with us. Hayley is the Chief Scientist at the Council for Geoscience in Cape Town, where she has initiated and is leading a countrywide continental shelf mapping program. She is also a Research Associate at the Centre for Coastal Paleoscience at Nelson Mandela University in Port Elizabeth. She holds a PhD from the University of Cape Town, carried out postdoctoral fellowship work at the Marine Institute in Bremen, Germany, and her interests include various aspects of Quaternary geology, read very young geology, and glacial-eustatic sea level change with a particular reference to our submerged deposits on the continental shelf around Southern Africa. She's also has a great interest in the human use of our ancient coasts. She is a member of numerous ongoing international multidisciplinary research projects to focus on South African records and has published more than 75 peer-reviewed papers and book chapters to date. Thanks, Hayley, and we look forward to your presentation and discussion afterward.
Thanks, John, and thanks everyone for having me here. Yeah, I think my bio that I sent through was H Cawthra is a geologist in Cape Town, so thanks for your kind words. And yeah, I'm really excited to be able to join you today. I'm actually at John and Marilyn's house and on the other end of the corridor, so it's a real pleasure to be out here. Thanks for inviting me. Yeah, I'm going to go through a couple of things today that are of perhaps interest and relevance to you in this area over here, and draw on some specific case studies from the areas around Walker Bay, False Bay, different parts of the Cape, as well as around the corner on the Cape South Coast. But at the core of it all, it's sea level change as a driver on sort of human movements in the past, and climate change and environmental change that I'm going to focus mostly on. Specifically within the, are we still online?
Fine, carry on.
I thought I lost Zoom, sorry. Yeah, specifically focusing on the Quaternary period, which is the last 2.6 million years of geological time. So just a quick few points of context before we get into it. Global change is obviously strongly influenced by plate tectonics and the configuration of continents on Earth. These scars on the seafloor attest to this, shown here in this image. I'm going to talk quite a lot about the seafloor and mapping it using different geophysical methods. And I really love this map. It was put together in 1977 and was the first map showing the morphology of the seafloor. I especially am a fan of this map because it was put together by a lady called Marie Tharp, who would have turned 100 last year. So she was quite widely celebrated. And thank goodness for that. I think back in the days when she was making maps like this, it was much more difficult for women in science. But what's striking about this map is that not much has changed necessarily about the way we view the seafloor, or we haven't learned too much new information about its morphology since the time that this was made. And most of the reason for that is that the technologies to map space and other planets are far more easy to apply than mapping the seabed itself. So we have better maps of the moon, Mars, and Jupiter than our own ocean floor. And we're chipping away at little areas at a time, but broadly, it's quite difficult to gain much progress on what we know out there. So zooming in towards Walker Bay, firstly, I want to bring out these erosional terraces because I know that they've been a topic of discussion on various field trips and a lot of John Blaine's work establishing these coastal trails. So there are erosional terraces that sort of define this coastal landscape, both onshore and also offshore. I've been diving out here before, and at about 40 meters, there's a massive drop off, very close to the coast. In fact, this is about 40 meters depth looking onto these houses on West Cliff, I believe it's called. So there are terraces onshore, there are terraces offshore, and there are various elevations of these terraces. Going back sort of several orders of magnitude maybe, distributed throughout the Cape Mountains are also older, higher terraces on the so-called African surface, such as shown on the bottom left, infilling these valleys in the Cape Fold Belt Mountains. The timing of the incisions of these terraces is quite debated, and advancements in the 1990s in apatite fission track dating have since really helped establishing the timing of these uplift events. One thing I want to point out from the outset is that the seafloor around Walker Bay is quite unique compared to most of the areas around the Cape, in that the Cape Fold Belt actually extends out onto the seabed. And the only other place that it really significantly does that is all the way over in Tsitsikamma. In between, there's this broad Agulhas bank, or when it was exposed as a landscape in the past, we call it the Paleo-Agulhas Plain, which is a completely different environment to what we expect out here offshore. I'm just going to show some of these uplift models because they're very interesting. And I'm showing the most recently published paper on all of this, which sort of brought together a bit of a review of existing data. It was published last year and was based on extensive offshore seismic data mapping to generate these sediment isopax thickness maps of the seafloor to look at a source to sink kind of process. Source being obviously onshore, the sink being the seabed, where the sediments end up at the end of their transportation or lifespan. Leading up to these first scenarios shown down at the bottom in plate E, Gondwana had just rifted apart, and the breakup of Gondwana is what shaped the morphology of our continental margin around South Africa. So we see sort of wrench faulting towards the Agulhas Falkland fracture zone as the Falklands and the Malvinas Plateau drift away. Then in plate D, we see thermal subsidence and the first bits of uplift. There are two periods of uplift that have been fairly well dated now, which go back to about 92 million years and about 76 million years, both in the Cretaceous. There seems to be an alternating response or changes in uplift and subsidence on different sides of the plate, which would probably make sense. It's unclear if it's being driven by a mantle plume or by other processes, but at least the timing is being better constrained now, if not necessarily the mechanism. Following these two phases of uplift in the Cretaceous, there was a fairly long period of low activity, low erosion. And then in the Miocene, again, about 25 to 15 million years ago, especially along the eastern side of the African margin, there begins uplift again. And this gives way to a model that a lot of people suggest as being slow and continuous uplift compared to pulses of uplift within that time. So we've experienced a lot of movements in the past. And now at the moment, there is some seismic activity, there is some neotectonic activity. And we're able to measure it better and better with the available technologies to do that. So a lot of work has also been done recently on the more young terraces, which are probably the ones that are more relevant right here at the coast. So moving further back inland towards the mountains, those are evidence of older uplift events. Right here at the coast, these are probably a little bit more recent. Again, another recent study was done, also published in 2020, that looked at the mid-Pliocene warm period in South Africa, which is about 4.5 to 3 million years before present. That's incidentally is a time when the world had more than 400 parts per million carbon dioxide, and is considered as maybe a worst case scenario likely analog for today's carbon dioxide levels. So there's been specific interest in looking at this geological time period, see what happened, how did the Earth respond, and how what the rock record shows that the response in Southern Africa was about a 30 to 17 meter above sea level rise in sea level above present, which would be associated with incision of terraces or reoccupation of old terraces. And this probably took place, anything from 4 million up to about 2 million years ago. The slightly lower terraces, and some of them actually within that same zone, also date to the early and the middle parts of the Pleistocene period. So at Pinnacle Point, some dating by Robin Pickering and colleagues has shown that at about 1 million years ago, sea level was approximately 20 meters higher than present, and carved a lot of these high-sitting caves. So the elevation heights along parts of the Overberg coast will probably be a good key to determining what sort of age you might be expecting those terraces to be. So what caused Cenozoic climates to change anyway? It's been a slow process with the changing of configuration of the continents, and the growth of these ice sheets that we see now began only really subsequent to the Cretaceous, which was an extremely hot time on Earth. So actually, if you look at a temperature curve through the Cenozoic, climate has cooled quite significantly from the beginning of the Cenozoic. There were a couple physical things that happened to trigger this, and that was the Australia pulling away from Antarctica, the Drake Passage opening, which is South America pulling away from Antarctica, and then the Panama Isthmus closing to set up this global thermohaline circulation of ocean currents, warm boundary currents and cold boundary currents. In conjunction with this, Milankovitch cycles also set in place. And coupled with all of these different factors, the environments around the world have changed quite drastically. So for example, grasslands in Africa and in many other continents as well emerged quite significantly in the Miocene period. And at Saldanha Bay, Langebaanweg, at the fossil park, for example, there are these beautiful plates of reconstructions of the environment at that time, several million years ago. There were mangroves, palms, and podocarpus trees growing in the area that's now just sort of coastal fynbos. So there's been a significant change in climate and environment over the last few million years, leading up to what we know now. And what we know now, we're within a sort of time of glacial, interglacial cycles. So every 120,000 years or so, we go from being in a complete ice age to a period of warming and back into an ice age. Or if you look at the curve in another way, period of warming through an ice age and back to another period of warming. Sea level fluctuates continuously with these changes in climate, these Milankovitch cycles, and opens up areas of continental shelves that are now underwater. But in times when the Earth is cool and sea level is low, these become exposed as landscapes. Southern Africa is a really good place to study these submerged landscapes because we're far afield with respect to the ice sheets, which means that our deposits haven't been scoured off, and we can actually look back to the later Pleistocene parts of the records. It's not a luxury that they have up in the north. So looking at these sea level curves, this is one that goes back about 400,000 years, and it shows that for about 90% of this time, sea level has been lower than what it is now. So these little peaks above the red line, which is present sea level, are the only times when sea level was at present elevation or higher. And the rest of the time it's been lower and the shelf has been exposed. So in this way, the continental shelf and the coastal plain are two parts of one continuous landscape, with the amount of exposure being dependent only on relative sea level at any time, of the emerged or the submerged portions. And these change proportionately and relatively with these changing sea levels. When sea levels move out onto the continental shelf, they take with them, of course, the coastal zone. So beaches, dunes, rivers, wetlands, all the features that you see on a coast now become imprinted onto what's now the continental shelf. And part of my work and my colleagues, we like to map those and try to unravel whatever we can about these past sea level and climate and environmental changes. From the rock record, interesting deposits are aeolianites or cemented fossil dunes. And here's some photos of us diving on them underwater. And beach rock, which is a really good indicator of sea level, and it's a cemented paleo beach deposit. If you can find these and you can map out their depths and you can date them, you can get a pretty good idea of reconstructing a sea level curve. Sometimes these rocks form extremely quickly. Shown on the right are some deposits that I've mapped off Durban, off an old whaling station on the Bluff. It's actually where I grew up in that area. And my life was spent surfing and diving on Blood Reef, and eventually I got to actually map it in my master's, which was really exciting. But during this work, I found an area with cemented harpoon heads and unexploded grenades and scary stuff that had been dumped there during World War II and the whaling time, which showed that these beach rocks are less than 100 years old, which was a little bit unexpected, but just shows the complexity of this coastal environment. So with beach deposits, what we're normally looking for to reconstruct sea level is an index point. So either like a swash zone or something specific that you can get an idea of the normal elevation in a modern environment and then project that back into the past. Along the Cape South Coast, there are not many true beach rocks, but there are often these foreshore and shore-face deposits. And where they meet is an approximation of mean sea level. So if we can find, especially vertical cliffs with this kind of exposure, that's an excellent analog for a sea level marker. So Quaternary rocks are quite ubiquitous along the Cape South Coast. They're shown up here in yellow, and they were first mapped by Jean Milan for his MSc. They've been very well dated now over the last few years using luminescence, which calculates when they were last exposed to raw sunlight as loose particles on a beach or in a dune, and then became buried. So luminescence essentially dates the burial age. But yeah, these go back to 400,000 years and give a really good record of past sea level change. Why I map the seafloor in the context of now is that people are fairly selfish, of course, and we all live too close to the coast. Well, not all of us, but about 600 million people globally. And we're concerned about the future because sea level in the past has been about 11 or 13 meters higher than it is now, in a time that is probably comparable to what we're expecting. And we need to know when it's going to reach that elevation and what we can do about it. So in order to understand what might happen in the future, we have to get a good grasp on the past. Another point of context is that people have occupied this environment for many, many thousands of years, tens of thousands of years. And the Cape South Coast, shown, some of these sites are shown here on the right, is one of the richest areas on Earth for Middle Stone Age deposits. In fact, at Pinnacle Point 13B, there's the oldest evidence of Homo sapiens dated yet anywhere on Earth. It goes back to about 170,000 years. So people have been occupying this southern coastal plain environment for many tens of thousands of years, and possibly since the time of the progenitor population of Homo sapiens. Again, I show that through most of this time, of course, the shelf was exposed. People followed the coast for the resources and probably the milder climates during glacial times. So the continental shelf has been extremely important as a piece of that puzzle to reconstruct the past. So to focus more broadly on the bathymetry of the area again, and the Cape's geological setting from a marine perspective, I'm really excited to be able to show you this super cool data set. So the Canyon data sets is from Anadarko Petroleum Corporation, and we have permission to use these data in our Council for Geoscience mapping program. They're overlaid onto Willem de Wet's bathymetry of the continental shelf. Willem de Wet did a master's in 2013 under John Compton at UCT, and he gridded all of the available bathymetry data that we had at the Council for Geoscience, plus fisheries data, to come up with an updated map of the continental shelf. Some of the things that are very striking to me are the Cape Canyon, which is comparable in size to the Grand Canyon. It's really massive, all the way off Saldanha Bay and going out to sea. The Cape Point Valley, another large incised canyon, which encroaches up onto the shelf, and many different incised canyons on the margin in between those and south of them. But also what I think is really interesting is the distinct boundary where the hard rocks end and where the sort of Mesozoic and Cenozoic deposits start, with a much smoother texture. Of course, this has got a lot to do with the breakup and the sharing of Gondwana. Some of the previous work in the area started in the late 60s with the first mapping program, which was a reconnaissance offshore mapping program in South Africa that ran from the 60s to the 80s. And as far as I can tell, the first map of the Walker Bay and the adjacent onshore areas was put together by John Rogers in a paper on the Bot River estuary and its evolution. John Rogers, back in the 70s and 80s, wrote a lot of fantastic papers with like with ideas that people are only able to go back and test now with the methods that we have available to us. There was a lot of fantastic work done in those years, and I'm showing here what I think is the first morphological map of this seafloor and adjacent coastal plain. Following on from that, John Rogers supervised a master's at UCT by Louis Lenoff, who extensively sampled and remapped parts of the bay to make these sediment distribution maps of Walker Bay. In 2011, John Compton, who was my PhD supervisor, published a paper which hypothesized how the expansion and the contraction of the southern coastal plain with sea level movements created these corridors of connectivity for people to move sort of around this rocky area and onto the flat Agulhas Bank area just to the east. He showed that when sea level was above 75 meters below present, that people were sort of isolated in areas where there were these barriers that prevented ease of movement. So this area has been readdressed a couple of times over the decades. And recently, just in 2020, after about 10 years of work, I was able to put together a sort of geological map of the last glacial maximum, which is based on many mapping expeditions and sampling and coring and collation of legacy data. And what's profound about the Cape South Coast is east of Cape Agulhas is this extensive Agulhas Bank and how that influences these past environments and ecosystems, completely different to anything we could possibly imagine today. I show this photo on the right. It's from Cape St. Blaise at Mossel Bay. It shows how the Cape Fold Belt rocks end just adjacent to the coast, and that's very much the case. There are a series of normal faults that have half grabens that have formed in the breakup of Gondwana. And for the most part, the Cape Fold Belt does not extend onto the seafloor out there. Hermanus is different though. So in Hermanus, in fact, the only 1 in 250,000 geological map that's onshore, offshore, that exists in our whole country is from here, from Hermanus. And it was published by Bremner and Milan. And I believe that Jean Milan lives in this area again now. He did a lot of excellent work on the Cenozoic deposits around here, and also these map products and lithostratigraphy descriptions, which we still very much rely on today. So this map shows a dissected coastal plain, dissected by rivers, quite heavily faulted, large embayments, a lot of sediments on the seafloor, but also a lot of the Paleozoic rock extending out onto the seafloor. De Kelders Cave is on the edge of this promontory, and on the other side is DYER Island, which I'll refer to a little bit later. So going around again into Table Bay and False Bay, I want to just say again that it's not the case as it is in Mossel Bay and on the Cape South Coast, where you have these sort of sweeping, sandy, fairly flat seafloor situations. These are really complex, rocky environments, and the hard rock deposits prevail. For instance, in Table Bay, my colleagues and I have been working there quite a lot in the last few years. And we have these excellent exposures of the Malmesbury. Generally, the Malmesbury group is difficult to map onshore. You've got to find it in road cuttings or on beaches because it's been heavily farmed, makes great soils. But offshore, we're able to get a glimpse of the structural features. We're quite surprised actually to see the sediment-starved nature of Table Bay when we started our mapping work. To zoom in on some of these features, the Table Bay Fault is this long orange feature running down here on the right. This has become quite interesting and important in our seismic models, working towards probabilistic seismic hazard assessments for an extension of Kuberg, for instance, and just for understanding the seismicity in the area. We can zoom into the multi-beam bathymetry data and see old paleo channel networks, which are of course very strongly governed by the structural fabrics. Gap dikes, there's an isoclinal fold, all sorts of beautiful structural features out there. We continue to map right now at the moment, and I've put some photos here of my colleagues We go out on the boats just sort of during daylight hours. We have a new boat, it's quite small, but it's wonderful. It's called the Environs, and it's very well equipped with everything that we need. So we're continuing our work in Table Bay, and following on from that, we're going to start work around here in False Bay. So to get back towards the geology and back towards this area, the Cenozoic deposits are made up of the BRISTOW'S group rocks, like I said earlier, first described by Jean Milan in the late 80s and the early 90s. Broadly, these consist of various formations. There's the De Hoopvlei formation, which is the oldest marine deposit at the bottom, probably Pliocene in age, overlain by Vanku formation, those large rolling dunes you see inland of France Bay as well. At Bartskersbos, I think that sort of area, you see these beautiful big dunes, those are Vanku formation. The Pleistocene Varnes Krans formation aeolianites are the ones shown in the picture here, which are well exposed on the beach at Walker Bay. The Klein Brack formation is the associated beach deposits, and that's been dated all the way back to 400,000 years, which is our closest analog of what we expect for the modern period of warming. And all of this is overlain by the Strandveld formation, which are the beaches and the dunes. That's Hayley van Asweg, and he's standing on the beach on the Strandveld formation over there in the photo. So some of the key features to look out for are, firstly, I've put out there, look out for fossil trackways, and I'll show you just now why. The opposing direction of bedding planes of these dunes can sometimes give an indication of the direction that the wind was blowing at the time that they formed as unconsolidated sand dunes on a coast. This is a pretty good paleo-environmental marker in some areas where there have been a lot of changes in the wind regime, specifically to the north of here. But generally on the Cape South Coast, the wind patterns have been dominated by southwesterlies through much of the Cenozoic. There are scattered outcrops in these strange forms because the cementation is not completely homogeneous, it's very variable. Patches of calcium carbonate that are much better presented than in other areas. Sometimes dissolution removes that as well. So it makes for these beautiful, almost karstic kinds of features on the landscape. And the Aeolian faucets are these beds at the angle of repose that make up the dune stratigraphy. So I said look out for trackways, and I've shown here some images of fossil trackways that we found in Aeolian dunes that are now cemented. All the way from Arniston to Woody Cape, which is in Algoa Bay. Charles Helm has been leading an ethnology project or a trace fossil project for the last few years. And I've had the privilege of working with him on it to contextualize the geology and understand the formation of these dunes and how these footprints can actually preserve in the dunes. It's quite fascinating. So we found hominin footprints, about 90,000 years in age, close to Brenton-on-Sea. That's an adult and a child walking side by side over a coastal dune when the sea level was a little bit lower and the coast was about 2 kilometers away. There's Cape Lion, which is now extinct. Giraffe, which is peculiar in this sort of environment, near Stilbaai. But when we made those maps of the Paleogalus Plain and we saw that grasslands would be promoted and probably savanna riparian systems down those big flood plains of the rivers like the Goerits and the Breda, perhaps it would have supported the presence of giraffes on that landscape. Crocodiles, monitor lizards, longhorn buffalo, which is also now extinct. And then there's this amazing rock, we call it megafauna rock. It's got rhinoceros, elephants, and longhorn buffalo, all in one deposit. Also giant Cape horse, Equus capensis, also now extinct. So the elephant footprints are quite ubiquitous along this coast. And again, that's significant because of DYER Island. I'll get to that just now. But I find it quite remarkable that we have this sort of different kind of paleo record of these sometimes extinct Pleistocene megafauna. And for the most part, I think we're really fortunate in Africa to still have some of our Pleistocene megafauna. On other continents, most of them were made extinct fairly rapidly into the Holocene, possibly as people spread their way across the globe. So coming into De Kelders Cave now, sort of from broad scale to finer scale, this is a really beautiful cave complex, of course, on the eastern edge of Walker Bay, close to Gansbaai. The De Kelders caves are incised into a contact between the Paleozoic Table Mountain Group sandstones, which are extremely hard quartzites, and overlain by the BRISTOW'S Group Cenozoic rocks. So along the contact itself, there's this raised conglomerate, and it would be really important and interesting to know the exact elevation of that, because it could either be Kleinbroek Formation, so 400,000 years and younger, raised beach deposits, or it might be very old De Hoopvlei Formation. It's not very clear yet. These are overlain by the Varnes-Krantz Formation, Aeolianites, which also extend all the way along the beach, and then are capped by the Strandveld Formation, unconsolidated sediments. The caves have been excavated for several decades, and some of the seminal papers were written by Anthony Tankard and Franz Schweitzer, looking at the geology and the paleo-environmental context of these caves. Again, like I mentioned earlier about John Rogers, I find it fascinating to read these seminal works and to sort of read these ideas and the thought processes. And again, I say that we continue to build on these original ideas now with technologies to refine dating and things like that. But a lot of excellent work has been done in South Africa for many, many decades. The caves were re-excavated and dated in the 90s by Fred Grine, Richard Klein, Curtis Marion, and others. So they've been readdressed several times. Some of the key highlights of the stratigraphy within the caves are that there are two within the complex. Both of them have archaeology. They're situated approximately 8 meters above sea level, which is good, because often caves that are about 6 meters above sea level or less in elevation have had their older deposits scoured out by the last interglacial, which was when sea level was about 6 or 7 meters higher than present, would have charred out a lot of these fine-grained deposits that were preserved in coastal caves. So if you have caves with archaeology that are higher than that sort of elevation, you've got a very good chance of preserving the older deposits too. I mentioned already that this formed on an unconformity. The geochronology or the dating has showed that these deposits range from about 125,000 years to 60,000 years, which is obviously it hasn't had continuous occupation, but that's a fairly long occupation history. The best preserved and studied sections are from 70 or 80 to 60,000 years. And at that time, which was Marine Ice Substage 4, a mild glacial, sea level was lower than present, maybe 50 meters lower than present on average. And the faunal assemblages and the paleo-environmental indicators in the cave suggest that at this time it was cool and wet, dense vegetation, and then as you get into older layers, there would have been more open grasslands as the shelf opened up more. Grazers were more common than browsers in terms of the faunal records. So some of these fauna included reedbuck, blue antelope, grijsbok, hartebeest, dune mole rats, Cape mongoose. Interestingly, De Kelders it's one of 2 caves on the Cape South Coast with evidence of human remains or significant human remains. And the other one is Classy's River mouth at Tsitsikamma. Dave Roberts, before he passed away, had an interesting hypothesis on the human remains at De Kelders. He was wondering whether the remains of people that had died in the cave were related to movement on an active fault. So he proposed that some of the faults in the area might be active and that one of them may have experienced some sort of seismicity or movement about 40,000 or 50,000 years ago, and that this might have triggered a rockfall that impacted the people living in the site. That hasn't been published. He's only presented it at conferences, but he was working on it before he very tragically passed away in 2015. So I've made some reconstructions using the bathymetry and moving sea level to these different times in these records. Firstly, just to contextualize what the shelf might have looked like during times like the last glacial maximum. The blue is obviously sea level. Pink dots are DYER Island, the Kelders, Hermanus, Betty's Bay, and Cape Point, just for some geographic context. And I've pulled sea level down to 130 meters below present here, which is the depth it was at the last glacial maximum. You can see how profoundly it opens up towards the east, just as you pass the rocky promontory off Cape Agulhas. And it's far more tightly constrained within the western areas, much narrower sort of shelf area for people to use, maybe up to about 40 kilometers wide at the widest, compared to up to 200 around the corner. So overlaying some very basic, very low resolution geology, you can see that, again, I keep saying it, but the Cape Fold Belt extends onto the seabed, and there are hard rocks out there, which makes for a different paleo environment to this Mesozoic and Cenozoic dominated area to the east. So specifically honing in on some of the time periods that were occupied at the Kelders Cave, at 80,000 years ago, sea level was approximately 20 meters lower than present. So at the Kelders, it means that Walker Bay Beach would have probably been expanded, probably a larger, wider, sandy beach kind of environment. And the coast was close, so within 10 kilometers at any point. So it would probably be expected that during that sort of time in the record, you'd see a strong use of coastal resources in the archaeology. As time went on and sea level was actually retreating at the time. So from the high period of the last interglacial, it was dropping towards the last glacial maximum. So about 60,000 years ago, sea level is 48 meters below sea level. Yeah. So and this means that, again, the coast is still relatively close to the Kelders, but obviously a little bit more distant than it had been before. And this links into the marine isotope stage 4 records that I mentioned earlier, with some influence of grassland and those interesting faunal elements that were preserved in the bone records of the cave. Ultimately, sea level dropped to the last glacial maximum, which was 130 meters below sea level, opening up this wide coastal plain. And this is when John Compton's hypothesis kicks in, of people were able to then move between these areas with relative ease compared to before. So at this time, we probably expect more extensive grasslands. People were now
Sorry, we lost your voice there for a while. Just backtrack again. Backtrack a little bit and say that again. Thank you.
How long?
No, just
We haven't lost it at all.
Oh. No, I was just saying that I was walking you through the sort of sea level change linked to the environmental change at the Kelders Cave. So 80,000 years ago, sea level's about 20 meters lower than at present. The coast is close, and people were probably exploiting coastal resources because of that. About 60,000 years ago, sea level is now about 50 meters below present. The coast is still relatively close, but at this time, we can see why there might have been an opened, expanded grassland kind of ecosystem in marine isotope stage 4 and different kinds of fauna available to hunter-gatherers at the time. By the last glacial maximum, anything from about 26,000 to 18,000 years ago, sea level is approximately 130 meters lower, and this southern coastal plain is opened. And according to John Compton's hypothesis of coastal expansion and contraction, people probably would have been able to move with relative ease from this western region around the southern tip towards the eastern regions or the Paleo-Agulhas plain. I'm lastly going to share some thoughts, if you like, on the recently discovered elephant tooth at DYER Island. So if you cast it over to the right over here, you can see the coastline. This is a zoomed in bit of the Hermanus 1 in 250,000 onshore offshore map. The coast around Gans Bay, Pearly Beach, and DYER Island shown in the red circle. There are like I said before, it's dissected by several faults, and DYER Island is probably Table Mountain Group sandstone rocks. This, interestingly, would have formed a land bridge to the modern coast for significant periods of time. And the base of the island is about 10 to 20 meters deep, depending on, of course, where you are. So the discovery of an elephant tooth on this island, I suppose, is not entirely surprising. To me, the most obvious way that an elephant could have arrived at the island would be when sea level was lower. This would have formed a land bridge, and elephants or any animals and people would have been able to move freely across that exposed landscape. This would have been the case from 115,000 years ago till about 8,000 years ago. So that's a long period of time in which there could have been this free-flowing movement. Before 115,000 and after 8,000, the island would have been severed from the mainland as an island and separated by the sea. And then, I mean, elephants have been known to swim. This has also been recently documented in Cyprus, interestingly, or maybe being transported or perhaps even washed across during a storm or something like that, maybe a dead elephant or dead fauna. But to me, I mean, I think that the tooth would absolutely need to be dated and the sediments in which it was found contextualized to get a better picture of whether it was actually in situ or if it had been transported there. And if a sort of more detailed study were to be rolled out, I think this would be really significant for the area, understanding the paleo-environmental history. Also interesting would be to compare actual fossil to these elephant trackways that we so commonly find in the cemented aeolianites on this coast. So maybe give an idea of what these elephants were eating, where they'd been grazing, where they were migrating to or from. So there's a fascinating opportunity here to initiate some really important and interesting research. Actually, the last thing now that I want to mention, while on the subject of paleo environments, is the vegetation. So Strandveld is richer than most other Mediterranean climate areas globally. So these coastal fynbos kinds of plants that we have here in our Strandveld, compared to Chile, Mediterranean countries, California and Western Australia, has a much higher species abundance. And a very good friend of mine, Richard Cowling, who's a fantastic fynbos botanist, he's often wondered what on earth this is all about. How did this Strandveld become so complex, and how did it manage to evolve in such a constrained area? But when we started our work together on the Paleogallis Plain and we opened up this landscape during times of low sea level, and with my geological mapping, we were able to see that there were massive distributions of dune fields out there, possibly something in the order of Alexandria dunes, just not as high. He had a bit of an aha moment and realized that Strandveld now occupies 1.2% of the Cape Floristic region. But there would have been a 23-fold increase in the amount of space available for the Strandveld in this fynbos thicket dune mosaic during the times of low sea level on this Paleogallis plain. So it made sense that this is such a complex little part of a little biome, because it actually would have, it's now been mostly submerged. So it's mostly extinct. It's an extinct part of the ecosystem now that it's been submerged. So it's a little sliver of something that would have been much broader, that's kind of remnants of these fluctuating sea levels in the past. And I think it's a beautiful example of something very tangible that we know and we can see and we can understand how these changing ecosystems are extremely complex and extremely based on much bigger things like changing sea levels. I also have a friend and colleague called Kirsten Brown. She sampled the Speleothem and De Kelders drip cave for paleoclimate work to measure oxygen and carbon isotope ratios through time to see how the environment and the rainfall has changed in the past. And her work is still ongoing, but perhaps when she's done with it, she'll be able to present you some really interesting information on that in the next few months, maybe a year. So that's all from me. Thank you very much, and especially for hosting us, John and Marilyn. And I've popped up a list of references. Oh, I see some of them are incomplete, but yeah, anyone wants to do further reading, you're more than welcome to get in touch with me. I can send you some papers. Thank you very much.
Excellent. Thank you for a fantastic presentation. Just going to have you turn on your camera just a moment.
It says the host has stopped it. So
yes.
Oh, there we go. Hi.
Okay, John, you want to host us the questions?
That was wonderful. So let's throw it open to the floor, and I'm sure there's lots of room for discussion and some good questions. Who wants to kick off? John Blaine? Mike Dormer?
Say it's such a fabulous story that we can't wait to incorporate as much of this as possible into our new endeavors for generating tourism opportunities around here. And I guess what would be the most exciting thing would be to find some remnants of vineyards out in the sea floor.
That would be fun.
Okay.
Hayley, I just want to say thank you. That was absolutely fascinating. I'm puzzled by the photograph of the elephant's tooth, because to me it looks like several people's dentures caught in rock. You know, I'm fascinated by that picture. Could you just tell us how you know it's an elephant's tooth and not some waste dentures?
Letitia, I don't know. It came off. That's. I found that picture on the internet of the elephant tooth from DYER Island. So maybe John Bristow can say something, but I'm certainly not an expert on teeth, unfortunately.
Can you bring it up again, a picture?
Yeah.
Well, the first thing is, how old are your dentures, Letitia? Are those from vintage years?
No tails out of school.
Can you see it?
Yes.
There we go. Thank you.
Yeah. As opposed to a tusk, I can also not see for the life of me how that thing, apart from being an African death mask, tooth.
There's some fascinating. I mean, obviously, biologists and paleontologists are highly skilled in identifying these things, and some teeth are really complex. I mean, I've got some mussel cracker teeth at home, some fossilized mussel cracker teeth, the fish. And those are also just similarly complex. And they're actually, Richard Cowling and his wife Shirley gave them to me to make some jewelry out of them. And they're fossilized mussel cracker teeth. And they're also just as beautiful and funny looking.
I mean, maybe comment, Hayley. I mean, you're looking at a big molar. I mean, and those elephant molars are sort of like a cluster of semicircular structures, which I think you can see in that. Okay, and to put it in context, and we should have actually given you the picture, Gavin Lundy, who lives down the road in Royals, quite recently, as of a couple of years ago, found a very well preserved big elephant molar on the beach at Betty's Bay above the high water mark. So, and I think his grandson picked it up. So, and that one is very well preserved. So we're going to also get hold of that and give it to Hayley and her dating experts to go ahead and date. Maybe you want to explain how you do the dating and it's not destructive, Hayley.
Well, I mean, I don't personally obviously do the dating, but if we can get a permit from Sarah and a group of researchers together to collaborate on contextualizing all of this, then we can get AMS, accelerator mass spectrometry, radiocarbon. It's like a sort of new fancy version of the old radiocarbon dating, which uses much less sample material.
Yeah.
That can be done in an almost non-destructive way, and isotope analysis that can identify what this animal itself was eating before it died and through its life would also be extremely important. But of course, we would need to go through due process and get permissions and permits and people together to do that. But to throw a multidisciplinary team at something like this, I think it's a great opportunity to do that. And it's good as well for the parks and the people at Dyer Island, the conservancy there too.
Greg Botha has a hand up. Greg, you want to ask your question?
I just want to put on my video.
Hi, Greg. Nice to see you.
I can't get my video.
Yeah, you might still be muted by Gert or Henny.
Hey, we see you now.
I've just got a recent elephant tooth here that I can show.
Fantastic.
Oh, thanks, Greg.
I don't know if you can see it. I can't see myself.
Yeah, no, you can see.
Stop your share. Hayley, stop your share.
Okay.
Now, Greg, can you put...
Yeah, fantastic. You can see that same structure there, Greg, and everyone else. You see the structure into the tooth. Yeah. Yeah, these are serious dentures, Letitia.
Yeah,
Thank you, Greg. That's fantastic.
absolutely.
Now we can see the resemblance. Now we can see it. Thank you.
Yeah. Wonderful. Didn't realize you kept your dentures on your side desk, Greg. Okay.
Dale, your hand was up. You want to ask a question, Dale?
Yes, and also my thanks, Hayley, a fantastic presentation. I'm a hydrogeologist, and I'm just wondering if in your offshore work, whether you came across any evidence of submarine groundwater discharges. That's one question. And then a second question, maybe potentially linked to that, is those canyons off the Cape Coast. Any association between those and the Colenso Fault, which also extends into the bay at close to where that canyon was mapped?
Kelders. So the groundwater discharge, I've read about that, and I think we have potential for that in areas where we have faults running onto the seafloor. I know that in Algoa Bay, people have, for years, there have been stories about fresh water bubbling up close to Bay Island. Around the Western Cape, we haven't actually mapped any evidence of that. But we also don't map with a forward-looking sonar that would identify seeps and things like that in the water column or differences in that sort of velocity. So we can map out faults and we can potentially see if they've been active and then hypothesize, how that might link to aquifers, but we haven't actually found strictly evidence of that. And then on the seismicity, on the Colenso Fault, so I didn't show a map with all the faults in the area, but the Western Cape, especially here around the syntaxis, is full of faults. They're normal faults, they're reverse faults, they're strike slip faults. And in fact, around here, specifically on that southwestern Cape margin, we're in an area where the horizontal maximum stress fields change. In the south, it's sort of west-east, and just up towards Saldanha Bay, it's northwest, southeast. So it's a very complex structural area, but it's full of faults from different times. I mean, there's been the assembly of Gondwana, the breakup of Gondwana, and then some neotectonic processes too. But I actually recently plotted up, last year when we had those seismic events, I plotted from our colleagues in Pretoria some of the seismicity clusters from our seismologist colleagues. I plotted them onto the bathymetry, and there's some very close correlations with the positions of the canyons, pockmarks, where there are big lithological boundaries. It's really interesting, and we're actually doing a lot of work on that at the moment for Eskom. But yeah, it's quite a fascinating and complex story, and I feel like we really need to better constrain these big faults in the southwestern Cape area before we can really understand much about the specifics of the seismicity. But yeah, there's the Colenso faults, and it's at the same kind of orientation as a lot of the other big faults in the area, which are along that northwest, southeast stress axis or stress field within that sort of zone.
So Hayley, on the canyons in particular, what scoured those? Were those then picked up by previous drainages and obviously following the fault lines? Is that what you're saying?
Probably. So a lot of people have worked on the canyons, and there are a lot of different hypotheses around it. So the first work on the Cape Canyon was, I think, by Simpson and colleagues in the 1960s. And it's been worked on right up till the present. There was a master's on the Cape Canyon in 2017 and an honors project on the Cape Canyon just last year. There's been a lot of work going on, but still some people would argue that it formed during the Cretaceous, during the rifting, and it might be fault controlled. Others have said that it's probably from ancestral olifants and orange rivers that have flowed out onto the shelf and carved these things. They're different ideas, but most people seem to believe, including Rochelle Wigley, who did her PhD there in 2004, that the Cape Canyon was probably incised during the Pliocene. That seems to be the most recent school of thought on that. And whether it's fault controlled or drainage controlled, I don't really know, but maybe John Rogers, or I don't know if John Compton's here, but maybe they would know better than me. Please feel free to jump in.
John Rogers.
No, I think John Compton supervised, I co-supervised Michelle, but John Compton was the main one. And basically, they saw incision of Pliocene sediments. So that's why it's a relatively young incision. But exactly the final story, I don't think is out yet. She lives in New England now.
Okay. Right.
John, I think Michael wants to say something. Michael, you're unmuted. John? Michael, you're unmuted. Do you want to ask a question? Probably.
Okay,
Right.
we'll wait for him to come back. But Hayley, just give us a little insight into the dunes and, you know, these very young dunes, the BRISTOW'S. Obviously, they were very large structures. You know, if you look at those dune fields sort of east of Stanford and down towards Gansbaai, I mean, those structures must have been enormous. Is that, you know, what's the difference from today to then? Other than the fact that we planted all these stupid exotics on the dune fields and screwed them up.
It's difficult to know exactly how big they would have been, John. So the cemented remnants of ancient dune complexes are not necessarily reflective of how big those dunes were at the time. So these might be little cemented cores of a much larger system, or they might represent, for the most part, the size of those dunes back then. But generally speaking, dunes are very obviously geomorphologically driven. The position and the size of dunes depends on wind, sediment supply, the substrates on which they form, you know, whether it's conducive to that, whether it's flat lying or steep. And they'll generally accumulate where you have interception of all of these favorable factors. So you might find that when sea level is slightly lower and Walker Bay is more exposed, that there's a slightly flatter part of the coastal plain that would allow more sediment buildup to accumulate and then to actually remain there. That's also the thing, is to sort of keep it in place. But generally the dunes in the southwestern Cape form downdrift of river mouths. So here there's the Klein River and the Bot River, and longshore drift moves from north to south. So generally it'll capture the sediment coming out of the rivers, allow it to accumulate in these coastal embayments, and then the wind and the other processes keep them in place. So I guess the age of the dunes, you would need to know the specific age of the part of the dune field in a specific area in order to make inferences about what happened there necessarily. And I don't think those dunes right there have been dated. So they've been dated at De Kelders Cave. They're about 88,000 years old. If the dunes on the coast are the same age as at De Kelders Cave, then sea level would have been about 20 meters lower than present, so a bit more of a coastal plain. I don't know what the rainfall amounts were like at the time. Hopefully Kirsten Brown's work through the Speeder Thames will show if it was higher or lower. So sometimes if you have more rainfall, it flushes more sediment onto the seabed, and then longshore drift would allow it to accumulate onto the coastal zone and build bigger dunes. So it's pretty complex, but yeah, I think that perhaps there was more accommodation space than there is now at the time, and which is why those cores of those cemented cordons look more impressive maybe than the current unconsolidated dunes.
Mike Dormer has a hand up. Mike?
Thanks, Hayley. I just wanted to ask a question around about the Strathspire Dulles area, because it's commercially important in terms of fishermen, and they refer a lot to the banks, and the banks go out, you know, you get 5 kilometer bank, you get 4 kilometer bank, and then it goes deeper, 8 and 12. Those banks are not, as I sort of originally thought, of a continental or a drop-off. Are those related then to Cape Fold belt structure?
Probably, Mike. I personally don't know those terms myself, but I would imagine that that's got to do with the sort of Paleozoic rocks that extend out there and probably have terraced drop-offs within them. So here off Hermanus, for example, we have there's that 40-meter terrace and there's a 75-meter terrace. And John Compton has done a lot of thinking about how old those might be, correlating it to sea level curves, and he's looked at sort of reoccupations of different elevations. And John believes, and me too, that they probably have been carved within the last sort of 2 million approximately years, so within the Quaternary. There might have been something there to start, but they would have certainly been reoccupied and more heavily eroded in that time.
Hayley, John Compton was online. He's logged out, but he left a message saying, "Great talk, Hayley. Thanks so much. The images were beautiful and wonderful to have an update on the latest work. Good work."
Thanks. He was my supervisor for my PhD. He's a good friend.
Any other questions?
Kurt?
Go ahead. Go ahead, Jenny.
It's Jenny Morris speaking. Hayley, thank you for a fascinating talk. I have a question which you've sort of perhaps answered as a byline on something else. It's about the ancient Orange River, which I understand used to empty out onto the west coast north of where the Olifants now does. Is there evidence under the sea of this river? Has it left a canyon, or it has left a delta or some sort of feature?
Mind if I defer that to John Rogers? That was his PhD topic.
Oh, okay.
No, basically the argument is, can you hear me?
Yeah.
Yes, we can hear. You can hear you.
Richard Dingle was working. I was working on the surface of the continental shelf of the Namaqualand in southern Namibia, but Richard Dingle was doing the seismics, and there basically was a very big deposit of sediment under the continental shelf of the Orange, of the Olifants, and then it stopped being deposited, and deposition then moved to north to off the Orange where it is now. So that it was more a seismic interpretation of the seismic stratigraphy of the Olifants and then of the Orange. He's retired to Cambridge now. I visited him 2 years ago. Very active man.
Thank you.
I just want to mention, in passing myself, just a comment. I'm currently reading a new autobiography of my cousin, Maeve Leakey, married to Richard Leakey, and she's been working in the sediments of northern Kenya. But her mother-in-law, Mary Leakey, worked in northern Tanzania and found these beautiful trackways of animals, but also hominins in a place called Lake Toli. So I knew that over the years, from Tony Tankard on, that tracks have been found through work of people like Dave Roberts, obviously, but I didn't realize there were so many. And the one of the hominin with the parent and child, I think, was very, very nice. And I'm quite curious to know where that was, the hominin and child.
Brenton-on-Sea, John.
Okay.
It's if you walk down those steep steps at Brenton-on-Sea.
Right.
I actually took the Friends of the Museum there on a field trip a couple of years ago. There are 333 steps, Munro Bloch told me. He counted them. So you go down the steep sort of the Table Mountain Group sandstones, and then there's a little embayment that's filled with aeolianite, Pleistocene aeolianite. and there's a cave there, and these are positive features on the ceiling of a cave. And subsequent to that, we've actually found a few more hominin trackways in Gokama and 2 sets in Gokama and also near Gericke's Point. So all on the Cape South Coast.
Thank you very much.
Sure.
I mean, just going back to the discussion and the Olifants River, and you know, there's an added component there, and John will probably be aware that in that if you look at satellite photographs, there's a whole series of pans that sort of stretch from more or less the Olifants River mouth, and I'm talking further inland now, back towards Prieska and, you know, that section of the Orange River. And of course, the other thing is that, and I see Mike DeWitt is not on the presentation, but the diamond deposits on our west coast, the South Africa west coast, really start sort of around the mouth of the Olifants River and then progress northwards up to the Orange. So the general sort of theory is that there was an ancient Orange River, which the initial exit was down somewhere around the Olifants River mouth. That brought diamonds, alluvial diamonds from the hinterland, from the kimberlites, weathering of the kimberlites, dropped them on the west coast around the Olifants, and then the longshore drift effectively distributed those diamonds northwards back up towards the Orange. And then along the way, the Orange River obviously shifted. There was river capture with whatever it was, the pre-Karoo River or the Fish River, and so we ended up with the Orange River mouth where it is today. So there's a diamond component to that story as well, Jenny.
I find the whole notion of the Orange River having emptied out, you know, further south, very interesting, and looking at the history, you know, the geological times and why things got captured. So thank you, that's very helpful.
Yeah, we'll get Mike DeWitt to give us a talk sometime on, or John Ward, who's the expert on our amazing diamond plazas off the west coast, particularly in Namibia. But you know, there's a fascinating story on pre-Orange River positions relative to our diamond deposits as well.
Dale Barrow is logged out, but he left a comment that you might want to comment on. He said lots of potential for submarine groundwater discharges along the coastline, particularly with the TMG aquifer extending out beyond the coastline quite significantly along the Southern Cape. You might want to comment on that.
Yeah, I think that's what he raised in his question. So there was a paper published about 6 years ago, I believe, on let me get this right. It was pretty much about these aquifers, and when you drop the hydraulic head during changing sea levels, what happens to the water table. And there was a suggestion that the BRISTOW'S basin might have quite a lot of water that's been sort of funneled via the Table Mountain Group aquifers. And then I've read this very long ago, but I can find out those details, but I remember it was definitely about the Table Mountain Group, the dissected aquifers feeding into the Mesozoic basins, and the BRISTOW'S basin having potential to store this water, and whether it would be sort of expelled now under the sea or available as a water table when sea level is low. But the source rocks of the BRISTOW'S basin were deemed appropriate for something like that. So yeah, that would be on the Southern Cape. That's the BRISTOW'S basin is off Arniston, Struisbaai, that area.
Any other questions? I think, John, you can wrap it up.
Okay, thanks.
Before you wrap it up, John, could I just say thank you particularly today to Hayley. That was fascinating. Thank you so much. And John, thank you and your group of geoscientists for sharing this whole course with us on U3A. It really has been a wonderful experience. Thank you very much, and good luck to all of you for your future ventures. And Hayley, enjoy the weekend here with us. Thank you so much. Thank you, John.
Thanks, Lucia.
Thanks, Letitia, and thanks, Gert. And yeah, it's been fun working with U3A. So, I guess we're all getting to the fossil stage, and it's really nice to be able to coordinate and work together on this. Thanks, Hayley, for your interest and effort of getting out here to talk to us, and most of all, I guess, to take us, go and walk us around in the field tomorrow and show us real rocks. And then I'd like to, thank again everyone for participating, and just ask if anyone, or those of you that are coming tomorrow, if you haven't let Gert or myself or Henny know, please do so. We're just keen to ensure we can organize a light lunch across at the Kelders, some refreshments, and just know who's there, and that we don't leave anyone behind along the way. And then also just be mindful of course, of bringing your masks and being cautious on the COVID side. But thanks, everyone. Thanks, Gert. Thanks, Henny, for running the show. Most appreciated. Thanks, Hayley.
Thank you.
Bye now.
Bye.
That was really good.
Yeah.
Thank you, everyone. Bye-bye. Thank you, Gert.
Okay. Bye-bye then.